Hi students, this class I would like to discuss mirror formula and magnification and some problems related to these concepts. First we will see what is mirror formula. So mirror formula is a relation. It's a relation between object distance and image distance and focal length. So the relationship between object distance, image distance and focal length is known as mirror formula. We don't have derivation for this, but if you can study class 12th physics, in that course you will learn how to derive this formula. So we are not going to derive this formula right now, so we will take it as granted. So the relationship between these three parameters, object distance u, image distance v and focal length is known as mirror formula. The simplest formula 1 by v plus 1 by u equal to 1 by f. Here v is the image distance, u is the object distance, f is the focal length. If you recall, we learned how to measure object distance, image distance. So this is the one of the example which I have taken at here to explain what is the object distance, image distance. It is a one of the case for concave mirror. So this is a concave mirror. And this candle flame, here it is our object, and here you can see, so this is image. Now the distance from the pole of the mirror to the object, so that we call as object distance u. We are representing that as small letter u. So the distance from pole of the mirror to the object is known as object distance. Similarly, the distance from object to image, so here it is the image, the distance from object to image is image distance, so that we represent v. So this is the simplest measurement. How we measure? Actually, we used to measure with the help of a long scale. So we will keep a long scale, or we can use an instrument known as optical bench. In the optical bench, these all readings will be there. So we will measure with the help of the scale what is the distance between the pole of the mirror to the object, that we'll take as object distance, and we measure the distance between the object to image, that we will take as image distance. And if you draw the corresponding ray diagram for this, so this is the corresponding ray diagram which we already know that. So in this one we need to measure what is the object distance. So here it is the object, AB is the object. Now we will measure the object distance from the pole of the mirror to the object. So this we will take as the length. The length we will take as object distance u. And in this case, the image is also forming at here a dash b dash, and that length from the pole to the image, so same length at here. So in this case, this is the only happens in this case. So that length we can take as image distance as V. So with the help of the scale, we can measure easily the object distance and the image distance. One more important point, that is, here for solving the problem, we need to use the new Cartesian sign convention while substituting all numerical values of u, v, f and r. So while taking object distance, image distance, focal length and r, radius of curvature of the mirror, we need to apply Cartesian sign convention. So this Cartesian sign convention we learned in the earlier classes. But for small information regarding this here, so this is the setup for concave mirror. So this is setup for concave mirror. This is a concave mirror. Now to this mirror, if you draw any spherical mirror will be formed with a sphere. So this concave mirror will be the forms with a sphere. So this is the concave mirror which forms a sphere. Why I am drawing the concave mirror sphere? Because we need to measure Cartesian sign convention for the focal length also. That's why you can see at here the focal length of a concave mirror is at here. Suppose here if I draw a Cartesian sign conventions, plus and the minus. So this is the positive x-axis and this is the negative x-axis. Okay. Now object is always negative. U is always negative, since it is always should place on the negative x-axis. It depends upon the position of the image. So image position value will be changes. But for concave mirror, focal length value always negative, because it forms because of the radius of curvature. So that is a small hint for this. Focal length of concave mirror is negative. Focal length of concave mirror is negative. So in the given problem, if it is a concave mirror, we should take its focal length value is negative. Not only focal length, and radius of curvature also. Radius of curvature of a concave mirror is negative. Radius of curvature of a concave mirror is negative value. So you should take for concave mirror, focal length value is negative value and radius of curvature is also negative value. So this is the important key point while we are doing the problems. But coming to convex mirror, so this is the case for the convex mirror. Convex mirror is also formed by a spherical mirror Now here you can see if I draw a sphere of this one, so this is the sphere. Now here we need to draw our next coordinate system. So if I draw at here positive and negative coordinate system, so along at here positive, I think it's not visible. I would like to take another color. So this you take as x-axis, and this is x-axis and this is the y-axis. Now if you apply Cartesian sign convention here, since it is a positive x-axis and here it is a negative x-axis, and this is positive y-axis and this is negative y-axis. Now here you can see where is the focal length. The focal length is at here. The focal length is at here. It is on positive x-axis. So focal length value of a convex mirror is positive. Focal length of a convex mirror is positive. Similarly, radius of curvature also. So I can write that point at here. Radius of curvature of a radius of curvature of a convex mirror is positive value. So these are the two important points for the concave mirror and for the convex mirror. So the points are the focal length value of concave mirror is negative and radius of curvature of concave mirror is negative, and focal length value of convex mirror is positive and radius of curvature of a convex mirror is positive. So I will show you one of the NCERT example. So the example shows the sign convention. So depends upon the mirror what they are given, so we have to take those the values. Now this is the problem, example problem here is given. If it is a convex mirror, the radius of curvature we should take as positive. Once we take that radius of curvature in terms of sign convention, then there won't be any confusion while solving this problem. So this is the point you should remember very carefully. And for concave mirror, now here you can see in the second example, the concave mirror focal length value in the problem is given 15 centimeter, but we should take it's a minus 15 centimeter because of the sign convention. So this is the smallest observation and we should carefully apply for given problem. Another concept is magnification. First of all, what is the meaning of magnification? Magnification gives the ratio of height of the image to the height of the object. So this is the formula we can use to calculate the magnification. If you remember, for the concave mirror, image gets magnified depends upon the position. Here you can see. So this is the image. So this image size is bigger than the object size. Now image become larger, so we need to find how much it is larger. How much it is larger. To find how much it is larger, so we need to use, this is the formula known as magnification. It is the ratio of height of the image to the height of the object. In simplest manner, we can write as magnification m equal to h dash by h. So we will represent magnification with a small lowercase m. It is the ratio of height of the image to the height of the object. How we measure the height of the image? So here in this case you take, now I want to write the object height. So we need to take the help of the Cartesian sign conventions. So here you can take positive x-axis. Similarly, on the other side, here you take positive y-axis, and down it will be as a negative y-axis. So everything we need to do with the help of Cartesian sign convention. So this is negative x-axis, and this is positive x-axis, and this is positive y-axis, this is negative y-axis. Now my formula is magnification m equal to image height by object height. So here how will you measure image height? So from here to there you can write what is the height of the image. From the origin we can measure. So this is the height of the image, we can represent as h dash. So here you can write the h dash divided by, and what is the height of the object? The height of the object from here to there. So we can measure that is along the positive y-axis. So that we will represent as h. So the magnification simplest formula, m equal to height of the image divided by height of the object. So depends upon the magnification formula, we can able to understand how much bigger the image is formed by the spherical mirror. Magnification is also having one more formula, so that comes under in terms of the distances. One more formula for magnification, m equal to, it is the ratio of the image distance to the object distance. So here you can see carefully. So u is the image distance, u is the image distance, and v is the object distance. There are the two ways to calculate the magnification, in terms of the height of the image to the height of the object, or in terms of the image distance to the object distance. And when you can take this formula, image distance to the object distance, keep in mind we used to use negative sign. Okay, so the negative sign tells about the image is inverted or not. Now if you can read this further NCERT, so you will understand the important points at here. So those are, the height of the object is taken to be positive, the object is usually placed above the principal axis, so automatically it goes to positive, and the height of the image should be taken as positive for virtual image, because virtual image always forms on the x-axis side, another x-axis side, so height always goes to positive. However, it is to be taken as a negative for real image. So real image in this case, so this is the real image. So the real image in this case, the height is negative because this is comes along the negative y-axis, and a positive sign in the value of magnification indicates the image is virtual. So in the magnification, we can say the total magnification is positive, then the image character goes to virtual. So we will understand better while solving the problems based on the focal length of spherical mirror, either convex or concave, and magnification.